this program. So double check if it is recording. Okay, it is recording. So this in this directory. I wrote a template for it. Coil.cpp. Okay. In our real CPP, we used canvas class to declare this Windows 600, 500. Okay. And the title is a wheel. Okay. We define some parameters that we will use later. Okay. And the radius of the wheel. Okay. And the initial angle of the wheel. Okay. And center is a point. Okay. At this point. And this is the function that draws a wheel at the center with radius R and angle A. Okay. So we pass in the center and then get X, get Y to get the XY coordinates. We call that CX, CY. Okay. There's pi. And then we set the color to be black. Okay. And now we just draw a circle and use gel line strip. Okay. We draw a circle around CX, CY. Okay. We start from this point, I stripped, okay, from this guy, and going to 0, right, from the x-axis, okay, CX plus R, CY, okay, and then we calculate the XY, we discussed this before, X equals R cosine T, okay, and Y equals R sine T, T is the angle between the radius and the x-axis, okay, so we start from slightly negative 0.1, and then until a little bit more than 2 pi. Okay. And the increment t is the angle by 0.1 each time. So we draw this circle. Okay. Just draw a circle, okay, nothing else. Nice strip, okay, nothing special. And here we set the color to be red and draw the center, okay, nothing special. Okay, draw the center of the wheel. And then here we just draw a radius. Okay, C plus R cosine angle. So at the beginning, A is equal to 0, right? Yeah. So this is just one radius. Okay, so we move to this point. Okay. And then draw this using green, okay, and then draw it to from this point, okay, on the circle. It's on the circle, and then we draw it to the center. Okay, this looks clear. And then the other thing is to draw for the trunk, okay, just a rectangle, nothing special. Given the parameter R, so just 2R times 2R, okay. This is just a rectangle. So in the display, we draw the trunk and then draw the wheel. Okay. And let's see how this looks like. This is the makefile, nothing special. Okay, this is a wheel, just one program. But we need the canvas. Okay, files. Don't use the default makefile. Use this makefile, then specify using this switch -F. Okay. That means this is the makefile I'm going to use. So there's the wheel. So you can see that we will draw a rectangle, the trunk, and then the circle, right? And then the center, and then the radius, green, okay? This looks like count. Right? But at the moment, we don't have any animation, it doesn't move, okay? So now let's add the animation to this program. Okay. Now to do animation, we will use double buffering. Double buffering means we draw the data to a buffer. Okay. When it's done, okay, then this buffer will flip to the front for us to see. If we do not use double buffering, the single buffer, when we draw, then we'll see things changes. Okay. Things change with the flickering. Okay. We don't want to see that. So we use a double buffering. Okay. And to switch buffer, you have to use this command, cut swap buffer. Okay. The back buffer data will be swapped to the front. Okay. And now let's use what we just learned, okay, to do the animation. Okay. We use this command. Cut visibility from copy this. So we this here. Let's make simple. Okay. So this is the function we need, and we have to define this with handle, visibility handle, and this is up here. Okay. It is here. Okay, and then we also need the timer handle. So we copy this. So we copy this. To here. Okay, so this defines the handle, except that there's no clear up there. We need to define the animation function. The animation function is what does the animation? We want to move the car and move the wheel. Okay. So what we need to do is to write this animation function. So we can do it here. Okay. Because you see, each timer is called, animate is called. Okay, so we write the animation function here. Void animate. Do it step by step. Okay. And each time this function is called, we want to increase the angle. Increase the angle by what increase the angle, depending on whether it is anti-clockwise or clockwise. Okay. So here we do the clockwise, so we decrease the angle. We decrease the angle by delta A. Okay. So we can define it delta A. Here, delta A is just 0.1 radians. Okay. Yeah, increased it by that. increase our angle, so the angle changes. And then we define the distance that's moved by the wheel. Okay, we call D. It is just equal to this angle times the radius. Radius times delta A. The angle is changes. It rotates. Suppose the wheel rotates a little bit. Delta A. Then the distance moved by it is radius times this delta angle. DELTA. It is given by this angle. And after that,
Professor,
yes,
check your spelling on the first line of enemy.
spelling DELTA.
Yeah, the word angle.
Oh, okay. Thank you very much. That's good. ANGLE. Okay. So we change the angle each time enemy is called. Okay. And the distance D is calculated. So our center, we wanted to be, it will be changed by this amount. So we can change the center, set to be center dot get x. This now becomes zero get. And the pure object oriented. If I were writing this program, I will make the x to be whole. Don't need to get this. There's D. Okay. There's distance it has moved forward. Y does not change. Y is the distance of the center above the ground. Okay. So the wheel is moving forward. And then after this, we just say crust post. We display the graphics to call display again. Okay. So it means each time the timer is called, enemy is called. And when an enemy is called, the center is changed. Okay. So the center is changed, the wheel is rotated. Okay. All this will be changed. Okay. And the center is changed, the trunk is moved also. Okay. So now we can, by adding this, we have animation. Okay. And then now you can see that we have animation, right? The car is moving forward. The wheel is rotating. It's so simple, right? Just we add a little bit more.
Why is it cut off there?
It's gone, okay, outside. Right? Now we can reset it. Okay, we can put a little bit more. Outside. Yeah. You can define a variable or maybe reset. Okay, here, Boolean. Okay, reset. Okay. And then in the keyboard, okay, if I press R, okay, then to reset is true. That means we start all over. To start over, basically, we put the center at the left again. So we can add a statement here. If we set, if this is true, then the angle start over again. Angle equals 0. We can start from the center to be the point at the left, -9, 0. So -10, -10 to 10, okay? We start at this point. And we set will be force until we press R again. We could will be set, start over. Okay, it is moving. Of course, you can easily add another wheel to it. So that's one of your homework problems in the future. And then when it disappear, I could press R. So we appears. Yes.
I was wondering how the green line is on top of the red dot in the middle.
Oh, why you have the green light and red spot? Okay. It is here. Let me draw the circle, draw the wheel. Okay. So first you draw the circle, okay? Maybe I do it here. Draw circle. Okay. So this is in black, okay? And here, put a point at the center. So this is in red. Draw the center. Okay. And this is the red. That's why you see the red color. Okay. And then this is to draw the beam, the radius. And this is in green, this color. So that's why you see this, okay, the red, okay, the red is this one. And then the green is this one. Okay. The angle changes. Okay.
Whatever is drawn last sticks up on top.
This is the line to the center. So we move the current position to the point on the circles and draw the line to the center. You can green. We first move to there. See that this. Draw this to the center. You can change the rate of the ambulation. You can make it faster. Change the handle. Okay. So instead of 100 milliseconds, Let's try it. 50. We can see that it's moving faster, right? Yes.
Can you tell if the circle is rotating every time it's drawn, if its position rotates, or is the circle static and only the axis is animated?
The axis and also the circle, because the center is moved.
And it's connected to the center so that the circle is actually being drawn in a rotating fashion.
Yeah,
Can you, since that takes processing power to animate that, and it would be unnecessary because we don't see it, how would you disconnect the drawing of the wheel from the drawing of the axis, so only the axis rotates?
only the axis rotate.
Mhm.
Well, the circle, the circle is the same thing. Still, you don't rotate the circle here.
Correct. I
You
mean,
just
does it
draw
actually,
in a different position. Yeah. So this is to draw the circle. Yeah. This is
so
to draw the circle.
the circle then is only like this and it just shifts, right?
Yeah,
The
draw
circle is not actually
a
being
different
animated.
center. Yeah. You see, you draw a different center. Okay, there's the nice strip, okay?
Okay.
C, because C changes, so your circle changes. 6CY changes.
Yeah, I understand. I was just trying to, I couldn't, just by looking at the code, figure out whether or not it's drawing the circle from a different angle connected to the radius every time, or if it's just leaving the circle as it is and it's only sliding it across.
Yeah, it's basically, you can say that the circle, we draw a circle at different positions, sliding across. So you can say that.
But if there was like a top pixel to the tire, it doesn't move, right? It's just like this.
Then we draw the whole circle. Okay. So first we draw it this position, and then later you draw it at this position.
Yes,
A new circle.
I understand that. I don't know if I'm asking the question in the right way, but I think I understand what it's doing now. Okay, thank you.
Yes.
Professor, I think what he's asking is if the circle is just sliding like this, or if it's also rotating along.
No, it's not rotating.
It's not rotating.
Yeah, it's just move, draw in different position, yeah, translate it, okay, as you can see from here.
Sure.
It is not rotating the circle. It doesn't matter, it just draw a new circle. The circle, it is this radius, it draw a different angle that makes it look like that it's rotating. Okay. We just draw a new circle. Yeah. Circle. Each time the center is new. Okay. Yeah, so you can instead of drawing one circle, you can draw two circles, and it looks like a car. Two circles, and then maybe disguise windows. Okay, so there's pretty straightforward the animation by making use of this. Okay, now let me give you a couple more examples. Here's another example that animate the movement of a ball. With ball curve. We can have different colors at the moment. We don't use it. Okay? To create 7 colors defined in this array. And well, we define our own point too. Okay, it will be easier than using a canvas. We don't use canvas here. Okay, another example. So here the XY topic. So then we don't need to use get X or get Y and change the direction. So we don't use the canvas, so we define the world window from 0 to 5,600, 0 to 600, okay, and clear color so that it's white, okay, and then draw with this color 0. Color 0 is black, okay, 0, 0, 0, 0, okay, at the beginning, okay. And then now we present both methods, the idle method that we discussed earlier and the visibility method. So here the timer handle the same, okay. And here, except that here we have the delta t, okay. Delta dt here is defined by delta t. Delta t is defined here. We can change that easily instead of article. Delta t is 0.1. Here. And now this is our animate. Okay, so we try to animate a projectile of a particle, okay, shooting into the sky, and then it falls back. Okay. So this is the initial velocities in x direction 10, and in the y direction 20. Okay, and this is the gravitational acceleration, okay, minus 10 meter per second square. So the precise area should be what? Actually, it's foot, I think. 9.8, right?
No, it's meters, 9.811 meters per second squared.
Yeah, it's 9.8 to be more precise. And now if the y value of the particle, the center of the particle is below 0, then we start over. Okay, we start over. And also, if x is larger than 5,000 out of the screen, we start over. The center is at 0, 0 again. Okay. So each time this animate is called, we increment the time. Okay. And then the displacement in the x direction, delta x, is given by Vx, right? Times t. That's your high school physics, remember? Okay. Velocity times time. Okay. And then in the y direction, it is given by, say, the initial velocity ut, right, plus half gt squared. You can remember your high school physics. Okay. Initial velocity times t plus half gt squared. G is the rotational acceleration. It's how we calculate the position of a projectile. Okay. And then we just increment the delta x, delta y. I mean, the center x, center y by delta x, delta y, increment down. So then you'll see that the particle will move along the trajectory. So these are animate. So we could use, these are all the same, except that we calculate the dt. It is 1,000 times delta t. Delta t is in second, 0.1 second, times 1,000. That changed to millisecond. Okay. It means after 100 millisecond or 0.1 second, it calls this again. So we use this method, okay, got visibility on this handle to call this. So when we call this function, you can see that This particle. And start right on the screen, it start off again.
It's like that VHS thing. Just hit the corner of the screen.
You could use the other method that I told you earlier. Use the idle method. We know this. The idle method, basically, this function is called. Okay, this one. Okay, again, so this is hard coded, so we call it every 100 millisecond. Okay, hard coded, and we call it animate. We get the same result. Okay, so you can see that idle method works. And now you could make it a little bit more interesting if you add a little bit more to it. Okay, maybe instead of writing that again, I just copy it. Maybe I move this ball graph to 0.cp and then copy. Here, I can draw the curve also with different colors, but I need to store the positions using a vector. So I include this, okay, the vector. Include the vector there. And so declared the Q, which is a vector. Then defines variable CP, which is the current point. When we do the animation, you use different colors. Each time it drops below 0, we increment this I start from 0. And both n colors. We use a different color each time we do the animation. The Y drops below 0. And then when the particle goes beyond the boundary, we clear the cube. Otherwise, we just do animation as usual. We calculate delta x, delta y, in increment center x, center y. But we have to remember the positions. The display, okay, we draw the points, okay, start from here, and then we lie to center, and we remember the current point to be center, so that when the center moves, okay, next time, okay, we draw the segment. And when we do the line to center, okay, so this is line to center, we have to start from the beginning of the cube. So each time we have a new point. The new point, we put it into the cube, okay, and draw the whole curve using this nice strip. Whole curve. And now, if you use this one, and you should see whole curve. You can see that, you can see the curve. And it changes color after it drops to 0.
Yeah. Does it change color after you resize the screen?
The what?
Does it change color after you resize this screen?
No, it changes color because of this. Here, okay. When the center goes below 0, okay, it changes the color.
Yes. Can you try resizing the screen when it's in motion?
The what? Yeah. It drops below 0, it changes the color.
While it's going, just for my curiosity, would you please resize the screen?
It changes color when it drops below 0.
Now, since the frame holds when you're resizing it,
Yeah,
is it still animating
the same thing.
in an like you can't see it, but it's still going? And then when you release it, does it catch up?
Yeah, because it is animated on the world window. On the world window. Yes.
How does it change colors?
Oh, okay.
Just,
Explain again.
It changes colors when it reaches certain points? Or
Just when it hits the bottom?
No, it is here. It changes color. So your Y changes, right? Y drops below 0. When it drops below 0, you set the color, okay, using a different color. Okay, you increment after that, you increment I. So next time you will use a different color. Okay, so you have these colors. Colors are here. So you
Oh,
yeah, colors, okay, black, red, green, blue, and then yellow, etc. Okay, let's try again. Yeah. You see that it changes color. It's for fun. Yellow, difficult to see. Let's go for all the colors. Then it goes back to black again, red, and so on. So you can try that and play with it. You can make another variation from this. It's basic. May stop. Pause the recording.